Hi viewers, this is my second video, and what I am going to explain today is differentiation and integration in a practical way. Right from our high school in physics and mathematics, we start to learn integral calculus and differential calculus, and we learn a lot of formulas there. For example, if you take in differential calculus, the differentiation of a constant function is 0, and a differentiation of a ramp function is going to be a constant function. And differentiation of a squared function is nothing but a ramp function. And in integration, if you take integration of a constant is going to be a ramp, and integration of a ramp is going to be a squared function. And all these formulas you learn in mathematics and physics. Now, can you understand this? Can you visualize it? In this video, I am going to explain all those formulas in a real-time situation. And I'm going to explain this through a story, so you can understand this differentiation and integration in a practical way. Welcome to Marty's 8. My name is Martin Chirangal, and I am a PhD research scholar in IIT Delhi. As I have told in the description that I will take all the experiments in real time and I'll try to make you understand in a practical way. Let's go to the experiment, and I am going to show you a 24 hours time-lapse video. Let's watch it. I think you saw both the videos, and also on the side you also saw some graph that is going on. By this time you could speculate what that graph would be, but I'll tell you that. So in the first experiment, what is the difference that you saw in the 24 hours time lapse? The difference that you could see is the brightness of the sun. During the day it was bright, and during the night it was dark, right? So I'm going to draw a timeline. So in x-axis it is time, and in positive y-axis I am going to take the brightness of the sun, and in negative y-axis it is absence of brightness, which is nothing but dark. So it is minus b. I am going to take the time lapse from 6 a.m. So at 6 a.m. it is just getting brighter, and at 12 noon it is going to the maximum bright, and by evening 6 p.m. it is going to get darker, and at 12 midnight it is maximum dark, and again at 6 a.m. it is going to get brighter. This is in India, so we get a graph something like this. If you draw the brightness of sun, so it's coming like a sinusoidal function. So in the second experiment, what you saw was a driving of a bicycle. In that you could see the speedometer, and you could also see a map. So you have a magnitude and direction, so it becomes velocity. So you could see that from till time t1 it's not moving, and from time t1 to t2 it is accelerating, and from there it is remaining at that speed. In this driving graph you could see two functions. One is a constant function where it has no value and where it has a value, and another is a ramp function. So now you are able to represent what you saw. You could draw the brightness of the sun as sinusoidal, and you can represent your driving velocity or speed like this. Now the question is, what is differentiation and integration? Integration and differentiation are inverse operators. Just like addition and subtraction and multiplication and division, this differentiation and integration are inverse operators, which means if you take a function and if you differentiate, and after that if you integrate, you are going to get the same function. So what I am going to do is, I am going to tell you a small story. From that I'll explain what integration is. So if you know integration, you know that the inverse function is differentiation. So let's go to that story. We'll see integration through a small story. The story is like this. I work in a city called Alleppey. The city is in Kerala, in India. and I need to travel to my hometown, which is in Kochi. The distance between Alleppey and Kochi is 60 kilometers. So I'm going to travel by motorcycle, and I'm going to travel in a speed of 60 kilometers per hour. I'm not going to accelerate or I'm not going to put any brake. So I'm going to remain at the same speed, 60 kilometers per hour with a direction which is north. So it becomes a vector which is velocity. I'm also taking my friend with me. Now let's draw the graph of this velocity function, okay? This is going to be the velocity function. Say I'm going to start the bike at 9 a.m. and as I am traveling at 60 kilometers per hour, I'll reach Kochi at 10 a.m. So it will take 60 minutes, right? I have told you that one of my friend is coming with me. He has a GPS app in his mobile, and I have asked him to track the distance travel from Alleppey for each and every 20 minutes, okay? I have asked him to take the reading of the distance from Alleppey for each and every 20 minutes, right? So if I start at 9 o'clock, 9 a.m., we have just started. So the distance traveled is 0 kilometers. And at 9:20, 20 minutes apart, we would have traveled 20 kilometers, right? We are traveling at 60 kilometers per hour. So each minute is 1 kilometer. So for 20 minutes, it's going to be 20 kilometers. And at 9:40, it is going to be 40 kilometers. And at 10 a.m., after 60 minutes, it is going to be 60 kilometers, right? From 9 to 9:20, at 9 it is 0. Till 9:20, I am not taking any reading, so it is going to be 0. At 9:20, my friend tells me that we have covered 20 kilometers and it is going to remain till 9:40. And at 9:40, my friend tells me that we have covered 40 kilometers. And therefore it is going to remain here. And at 10 a.m., we would have reached Kochi, which is 60 kilometers. So what do you think this 20 minutes is? It is nothing but dt. So dt is 20 minutes here. So now I'm going to do a small change. Instead of 20 minutes, I'm going to ask my friend to tell me the value at each and every 10 minutes. To tell me the distance covered for every 10 minutes. We are going to see the distance travel for every 10 minutes. Did you see as I reduced the dt, it became more smooth? Now what I'm going to do is I'm going to record the distance covered for each and every 1 minute. So did you see as the dt reduced to 1 minute, it became much more smoother. What if the dt, that is recording the distance for each 1 second? What if it is for 0.1 second? What if it is for 0.01 seconds? It becomes very smooth, it just becomes like a ramp. So you would have seen this statement when dt tends to 0 is what it means. When the dt becomes very 0, which is near to 0, it becomes a very smooth line. Say, I reached Kochi and I remain in Kochi for lifelong. I'm not going to move anywhere. I'm going to stay there. So what happens to this? The distance traveled from Alleppey is always going to remain at 60 kilometers, right? So this will never change if I don't travel or go anywhere. No, it is going to remain at this 60 kilometers for time infinity if I do not travel or go anywhere in the bike. On the side, you can see that s is nothing but distance or displacement and v is nothing but velocity. So ds by dt is nothing but velocity. Likewise, integration of v for some dt is distance or displacement. S is nothing but the integration of v for some time dt. V is the input and S is the output. So output is equal to integration of input for some time dt, right? And what is the conclusion that you could get? If the input is a positive constant for some time, the integration of that is going to be a positive ramp and it is going to remain at that point till infinity. Now, let me assume that I am going back to my workplace, which is in Alleppey, like after 2 or 3 days. So what I'm going to do is I'm going to put the reverse gear and I am going to go in reverse in the same speed. I'm going to travel in reverse with the same speed. Now I'm going back to Alleppey. So what is the distance from Alleppey? It is going to decrease, right? So as I reach Alleppey, the distance from Alleppey is going to be 0. Now you could get two conclusions. One, if it is a positive constant for some time dt, the integration is going to be a positive ramp. And if the input is negative constant for some time, the integration of that is going to be a negative ramp. Now you could relate all this with the formulas that you studied. Integration of a constant function is a ramp function. That is what you're getting. So what is integration? Integration is nothing but depending on the input for that time dt, it will either add or it will either subtract with the previous value. This is integration. And let me tell you about differentiation. So d by dt of distance or displacement is velocity. So this d means small change. For small change in time, see if there is a small change in distance. If there is a small change, then you can plot that. So I'll take 3 segments. So if you take in segment 1, for change in time dt, do you see any change in displacement? No. That is why it is 0 here. In segment 2, from here to here, you can see that s is changing with respect to time, right? So it is a positive change. So that is why it is a positive value. And here, right, it is remaining same. So there is no change in s with respect to dt. So again it is going to be 0. And here change is negative, that is why it is negative. So now I think you can visualize and you can understand what integration and differentiation is. Next I'll give you a small summary. Let's go to the summary. If the input is a positive constant for some time, then the integration of that is going to be a positive ramp and it is going to remain at that value till infinity. Similarly, if the input is negative constant for some time, the integration of that is a negative ramp and it is going to remain at that point till infinity. And we have also seen this formula where integration of a cosine function is a sinusoidal function, right? Let's see that. In the experiment of the 24 hours time lapse, you have seen that it is a sinusoidal function, right? In that, I started at 6 a.m. Here, I am going to start at 12 noon. At 12 noon, it is maximum bright. And after 6 in the evening, it is going to become dark. And after 6 a.m., it is going to be brighter and it is going to continue. So if you take this is a cosine function. It's a cosinusoidal function. What is the integration of this? Let's see. I'll divide this into 4 sections. Here in section 1, it is a positive value. So we know that if something has a positive value, the integration of that is going to be a positive ramp. So we can approximate that here. If it is a positive value, it is going to be a positive ramp. And in segment 2, you see that it is a negative value, right? It can be approximated as a negative constant. So what is the integration of that? It is a negative ramp. So I'm going to draw a negative ramp from here. And in segment 3, again it is a negative value. So I can approximate that here. It is a negative constant. So it is going to be a negative ramp again. So in segment 3, it is going to be a negative ramp. And in segment 4, it is a positive value. So I can approximate that with this, which is a positive constant. So it is going to be a positive ramp. So now could you see the integration of the cosine function here is a sinusoidal function. Integration of a cosine function is a sinusoidal function. The experiment that you saw, which is nothing but the brightness of the sun, also has an integration. It also has a differentiation. So differentiation and integration is there everywhere. Whatever you see, it has a differentiation and has an integration. This is what integration and differentiation in real time means, With these two results, you can approximate to most of the functions, In fact, I have used this in my previous video where I have explained what is F is equal to ma or the Newton's second law of motion. You can see where these integration are practically used. I would strongly suggest you to see the first video which uses these functions. Thank you for watching this video. Bye till we see in the next video.